Good morning and welcome to the Keeping Your Culverts Well webinar. And we're going to talk about common types of deterioration and maintenance and repair techniques for culverts this morning. I'm Willy Grimmke. Um, I'm a circuit rider for Cornell Local Roads, and I'm a former county highway superintendent, and I currently work with Greenman Peterson. If you have questions, discussion, any items, raise your hand or put questions in the chat, and we'll try and get to them as the discussion goes on.
Actually, Willie, they need to use the Q&A.
Oh, you use the Q&A. All right.
Yep.
So for this, you will get a PDH in New York State if you're trying to keep your license up, but it's only for the person registered. And you'll need to have your certificate of attendance. Other states, check with your local LTAP. Okay, learning outcomes. So what we're discussing today are common deficiencies in culverts, and then we will transition from there into PM, preventive maintenance, and review some repair techniques. So we'll start out with some questions. What is your primary job function? Administration, highway superintendent commissioner, engineer, field crew, board member, or none of the above?
All right, Willie, we have some answers coming in. Let's see. So we have a bunch of engineers today we have a couple, none of the above, administration, and some highway supers.
Okay, great. So, what is your primary job function? Highway maintenance worker, highway maintenance supervisor,
Oh, sorry, I did
engineer,
the wrong one.
or other? And I suspect engineer is going to score well on this poll.
Sorry, Willie, I did just the opposite of the other question.
Okay. So,
So majority of them were the engineer. Do you want to move on to that last poll
yeah,
question?
yeah, sure. Okay. Who do you work for?
All right.
Village, town, county, city, state?
Okay. Let's see.
Private?
We have lot of people answering. We have town, county, private, none for the weekend yet. Oh, couple for the weekend. Oh, yeah, results. All
Okay.
right.
So we've got a bunch of state and federal folks, county, town, and we've got a fair number of private. Great. Okay. And we'll move on to the next question.
You did that one.
We did that one. Okay. So if you are responsible for maintenance of culvert, or if you're doing design, how long have you had exposure to and worked with culverts?
Well, we have a bunch in the 11 to 20 years and 5 to 10 years. We have a
Great.
couple that are less than a month. Let me just share those results. 1 to 2, 3 to 5 years, all across the board.
Okay. So for the under 3 to 5 years, folks, there may be something new that you'll learn. And for the people that are in the 11 to 20, hey, you may have stuff that you can share with me that I haven't seen. Okay, we'll close that. Okay, if you have culverts in your inventory, span between 5 and 20 feet. We're not talking small pipes. How many do you have and maintain if you're, public or private sector that are steward of infrastructure?
All right, Willie, we have a bunch that are saying over 100, couple that are saying not sure. Oh, and I'm going to share those results.
Not sure is actually not an uncommon answer because a lot of agencies know they have a lot, but they don't know exactly how many. And it's not uncommon to have a whole bunch. Okay, so we're going to start with a little bit of nomenclature here. Parts of a culvert. The top is the crown. The bottom, where the water flows, is the invert. The widest part in an oval or round culvert is referred to as the spring line, and the area between the spring line and the invert is referred to as the haunch. And we'll get into the importance of the haunch as we talk about flexible pipes a little bit. In longitudinal section, sometimes we'll have an apron in front of our culvert to transition from the creek bed or waterway into the culvert itself. Sometimes we'll have a toe wall or cutoff wall to prevent or mitigate scour and undermining. We'll have the barrel of the culvert, which is the round wall part. We may have an end section. We might have a parapet up above, depending on the length of the culvert and the road configuration and how high the embankment is above the culvert. We will often have joints, and sometimes we'll have wing walls. Common culvert shapes come in all variety. Round is typical, but we also have elliptical, both horizontal and vertical elliptical, square, which we get for box culverts. We can have arch culverts, and then in the lower corner here, we've got a pipe arch or plate arch. Now, culvert materials. Common one is concrete, and concrete is rigid. It does not flex, it does not move. With round pipes, bedding is important. It has a smooth interior. If it's pipes, they're like 4 to 8 foot sections, so you'll have joints, and sometimes concrete pipes can be skewed. It's very commonly concrete box culverts are being built for large culvert or small bridge applications. And concrete, you can have round pipes, horizontal and vertical ellipticals, arch. Precast boxes is what you see in the lower photo being set. That particular one is bottomless. It's on a footing to maintain a natural stream bottom. Then we move on to flexible materials, corrugated metal. And corrugated metal is flexible, and much of the structural support is dependent on the culvert's interaction with the surrounding soil. To some degree, that flexible culvert is a form, and the compacted fill around it is doing a lot of the load carrying capacity. With corrugated metal, because of the corrugations, it has kind of a rough surface, which in some cases can reduce your flow capacity a little bit. Corrugated metal pipes come in sections that are about 20 feet, although sometimes corrugated metal can be plate pipes or plate arches that are individual plates that are bolted together and have joints and bolts all throughout. The metal culverts can be steel or aluminum. Round ones come up to about 15 feet in diameter. Plate pipe arches, 50-foot spans, and we would use a fair number of those when I was in county government. Bottomless, up to 55 feet, and they are flexible. And as we show some of the distressed photos, you'll see how some of the impact of flexibility. Another type is polyethylene, plastic. Like the steel or aluminum, these two are flexible, and their performance is dependent on interaction with the surrounding soil. You can get them with a smooth interior, which helps your hydraulic behavior. Joints are about 20 feet apart, and the nice thing about these is they don't rust. Okay. It probably goes without saying, proper installation will reduce maintenance necessary during the life of the culvert. If you put it in right to begin with, it will probably last a lot better. And the key to proper installation with particularly flexible culverts is good compaction around the haunch areas while it's being installed. So, common defects we get in culverts. We get debris and siltation. Our creeks and waterways carry a lot of stuff, and sometimes it accumulates. We get leaking joints. We get settlements and sinkholes, which aren't really a culvert defect, but they are a symptom of some other kind of defect. We can get scour and undermining at the inlets and outlets. For metal culverts, we can get damaged coatings. The inverts can be damaged or deteriorate over time. We can have localized damage. In concrete culverts, we can get cracks and spalls, and in flexible culverts, they can deform. So here's a photo of a twin arch. And we have a little bit of siltation, a little bit of vegetation growing on the silt bar, and this can reduce the capacity. Right now, in the photo, under a relatively low flow situation, all the water's going through one barrel, and the other barrel is largely silted up. If you look, you can see there's a little bit of scour in the barrel with the flow. If we get a high flow event, the culvert on the right isn't going to take a lot of capacity, and essentially the capacity of that has been largely negated, which could result in an overtopping situation. We also can get soil accumulating in our culverts. It reduces our waterway capacity. what you see in this photo is not something that's an embedded culvert that, DEC tends to like culverts to be embedded. So there's a natural bottom. What you see here is not the case. It's just dirt and debris accumulating. And looking at the situation, you want to understand what's going on and what's causing soil in your culvert. Is it accretion from the stream, or is it failed joints, or is it some other mechanism? Debris in culverts. If you get debris in culverts, it can cause a substantial reduction in hydraulic capacity. As you can see in this photo, there's a whole bunch of vegetation and a fuel tank stuck in this box culvert. Well, you get a bunch of debris in it, and it can cause overtopping, which can erode your embankment and approach fill, and that's what happened in this particular case. Back in 2005, the Hadlock Pond Dam broke loose, and this was basically the result of that dam failure. Lots of debris and lots of overtopping. So sometimes we'll have leaky joints, and they can be a result of a number of things. They may be separated or misaligned, which is what we see in the upper photo. There may have been damage during installation. If you, in the lower photo, you can see the bell on that concrete pipe has a big chip in it. They can open up. I was involved with a project several years ago where a culvert was placed on under a fairly substantial fill, like 25 or 30 feet high, and the soils below it were clay. And about a year later, we went out to do an inspection, and the joints had opened up because the fill above the culvert had caused settlement and caused joints to open up. Also, poor bedding and subgrade can cause joints to open up. Okay. Impacts of joint defects. Water can infiltrate or exfiltrate. You can get soil coming in. You can get seepage. And if you have soil infiltration, what that can cause is sinkholes or erosion in the pavement surface above the joints, or down below, it can destabilize the culvert. Here's one with the joint is wide open. You've got some destabilization because things are obviously moving, and you have a whole bunch of soil coming in. And sometimes the distress that's caused by leaking joints isn't always readily apparent. This photo was taken about a month after this road was repaved. There was a mill and fill project. So the road was milled, it was overlaid. The paving contractor used a vibratory roller, got nice, good compaction on the pavement. And then several weeks later, the municipality noticed that there was this little hole in the pavement. They went out, stuck the ruler down, and it was some, 4 or 5 feet deep, and dug it up, and it was like 4 or 5 feet in diameter. apparently the old concrete pipe that was there did not uh, fare well due to the vibration up above. It opened a joint up, and then with the subsequent rains over the weeks afterwards, caused that void in the pavement. We can also get scour at inlets or outlets. This is an extreme case. This was farther downstream from the other Hadlock Pond Dam outlet issue, but the water had ponded or was impounded on the opposite side of this embankment, almost to the top of the embankment, and it was rushing out of this kind of like a fire hose and scoured out that entire bank. Again, extreme case, but it demonstrates the point. Dense and localized damage. Sometimes installations aren't always as careful as you would hope. And if you're putting a culvert in, a corrugated metal pipe, and back over it with the track hoe, something like what you see could happen. And it has a number of issues. One, it can open the joints up. Also, it can have capacity impacts because this is a much smaller cross-sectional area than what was supposed to be originally installed. And then if we're trying to repair something like this, rather than dig it up and replace it, our options are much more limited because you're not going to be able to feasibly slip line this with a fair diameter pipe. And I talked about deformation a little bit. Here's a plate arch, and due to either overload or installation or some other factor, this has a fairly substantial sag or belly in it that has happened over time. If we have concrete culverts, they can exhibit some of the standard problems that we have with concrete. It cracks, it spalls. If we go take a look at what's happening with the cracking, what's the cracking pattern, it can give us a pretty good indication of what the mechanism is causing the cracking. If you have cracks at 12, 3, 6, and 9 o'clock, longitudinal cracks down the pipe, it indicates that we don't have great side support and the pipe is crushing. If you have cracks down at 5 and 7 o'clock longitudinally on either side of the invert, indicates that the haunch area wasn't properly compacted. And if you have good side support all the way around, we shouldn't have cracks at all. Now, if we have radial or transverse cracks, it indicates support, inadequate support at either the middle or end of the pipe sections. So looking at this photo, if you've got proper bedding, the pipe is uniformly supported, concrete culverts uniformly supported end to end. If you have a broken back or cracks up in the top, it indicates that the ends are not properly supported. And if you have radial cracks that are open in the bottom, it indicates that the main barrel is inadequately supported, but the ends are. And we move on to metal pipes and coatings. Most of our corrugated metal pipe is galvanized steel, and the galvanization protects the pipe for a period of time from corrosion. As that galvanization goes away,
we have a question in the Q&A.
Sure.
What are your thoughts on when to use #2 stone versus rubble/crusher for bedding and backfill of culverts?
It depends on the application and what you're trying to do, and also your conditions. If you've got a wet condition, like #2 stone tends to work pretty well because you're not going to get adequate compaction in a wet condition, and in reality there are locations you just can't dewater. If you can get it dry, a crusher, DOT type 2 sub base tends to work very well. And in some cases, but you want a material that you can get adequately compacted that will support the haunch areas of your culvert. Okay, back to coatings. So once your galvanization deteriorates, right now it's not a problem, but it means that you have the opportunity for corrosion to accelerate and to deteriorate your pipe. And I bet most folks looking at this photo could speculate where the normal high water line is in this culvert. Okay, corrosion, how and when it starts is usually in areas that are either completely submerged or right at the normal water line where there's that good combination of oxygen and water. And it usually starts with pitting, and you'll get these little pits or rust nodules, and then they'll break off and you'll get little pits. Water and soil chemistry tend to accelerate this. If you have acidic or saline water, you tend to get corrosion more quickly, and soils with low electrical resistivity tend to corrode metal pipes more quickly. You can get invert deterioration also caused by a couple of things, either abrasive bed load. You've got a bunch of sands, gravels, high velocity washing through the invert of the pipe and essentially abrasive blasting your invert. And in some situations, the water chemistry may cause deterioration also. And as the invert weakens or gets reduced in section, it may destabilize the culvert. Here we have photos of metal culverts with invert damage and corrosion, again, water or soil chemistry or abrasion. And what's happening with the one on the left is, in all likelihood, the galvanization got abraded off, and then it let the corrosion really take hold. And the photo on the right with the complete loss of invert. The pipe is no longer, the culvert's no longer around, and now we have structural instability. Now, sinkholes. This is I believe this photo was taken in California, and it's not of the culvert, but what it indicates is the culvert has a problem and the soil around it was washed away. So sinkholes are a big symptom that you have a problem. And it could be much more subtle, like the photo on the right. And in time, you may get, inverts that completely fail. And then you have scour underneath and the culvert being undermined. You may have inadequately supported or overloaded culverts that in time collapse. So what do we do to keep our culverts performing well? Well, things we can do are remove debris, sediment, vegetation, so they will continue to perform like they need to. We can also armor the inlets, outlets, and embankments for scour and erosion protection. So the method of removal of debris or silt will depend on what you have. The vac truck is not going to remove the livestock gate that's stuck in this culvert, but it could be effective for getting the silt out. You're going to choose the tool you need based on the type of debris, the size of the culvert, the access, and if you have any environmental restrictions and what those are. Do you have to contain silt and debris, or is it the time of the year when you're out there working where everything's dry, so it's not a concern? You have health and safety concerns. Is that culvert a confined space, and are you putting people in a confined space? What's the water like? Are there contaminants in it? If we have large debris, like wood, logs, beaver dams, etc., and typically at the inlet and outlet, can you use an excavator with a grapple on it or other large equipment? Cables with hooks to hook on and pull it away. Do you need to put somebody in the culvert? Can you get a skid steer in there? Variety of tools to choose from, but again, you need to be conscious of what's safe and what's environmentally sound. If you've got silt, back trucks work great. If you've got enough hose, bucket line, small skid steer, fire hose, water jet or sewer jet, and water jet, sewer jet, and fire hose are great, but you need to do some sort of recovery or collection so you're not putting silty water downstream. And a word of caution on the sewer jet is if you've got a corrugated pipe with open joints, that could make the open joint situation or the perforated invert problem worse. So if you have scour, how you do it will depend on the severity of it. You'll want to do a hydraulics analysis to make sure you're using the right material. If you've got a 5-foot diameter culvert with relatively low velocity flows, heavy stone fill will probably be overkill. But if you were using number 2 stone, it may all get washed downstream. So you want to pick the right material. Variety of strategies. You can use grout or geotextile. If you're working in the stream, you will need to make sure you have the most appropriate environmental permits in place and comply with those. Okay, this is a video. Michigan DOT had bottomless culverts, and they had scour along the footings, and this is what they devised to get riprap down along the toe of that footing for scour repair. This basically floating box is full of riprap. It's, light or fine stone fill. And they're lowering it down into the waterway with a crane. And then loading it into position where they want to drop the material. And then dropping it right there. Fairly ingenious. Sometimes for scour repair, you could do a riprap apron. This is a Georgia DOT detail. They use a 24-inch, their 24-inch, what they call type 1 riprap. In some locations, a concrete apron to transition from creek bed into the culvert may be appropriate. So now we get into repairs. If you have undermining, how do you repair it? If you have inverts, how do you repair those? And what do you do for joints, footings, and relining? So undermining repair. One of the things you can do is cut off wall, and it will prevent or retard undermining from happening, provided the cutoff wall is deep enough. It won't prevent the scour hole in front of the culvert, but it'll keep it from progressing beneath it.
Another question.
Sure.
It says, can you re-sleeve it?
We are going to get to that. We're going to talk about relining in a little bit later. Okay, so to construct a toe wall or cutoff wall, basically you need to dewater. You need to make sure it's adequately designed so you're down below maximum potential scour depth. Form anchored to the existing culvert. Place, cure, backfill, restore the stream. If you have invert problems, like we saw in some of the photos where the invert was heavily perforated, gone, non-existent, etc., but the rest of the culvert's in good shape or basically intact, you can do invert repairs. We can do a concrete paved invert. We can do armor plates. We can do geosynthetic cementitious composite mat. So here's a photo and diagram of concrete paved invert. Does require stream diversion. The area of the invert needs to be cleaned. If you have any undermining or perforations, those need to get filled. concrete is formed and placed, cured, and basically in the photo you see there's a new concrete invert in the bottom of that metal pipe. That's New York State DOT did that with their own forces on Route 29 in Washington County. In some locations, an armor plate can be used. This is a Caltrans detail, and they used abrasion resistant plate in the invert and basically weld it in place. It does spread the flow out, so you don't have a concentrated flow under low flow situations, but it will resist abrasion. So here's a couple of photos of that being installed. And as you can see on the left, it's flat. There's no defined invert. And then, concrete is placed or grout below the armor plate. Geosynthetic cementitious composite mats. Basically what this is, it's a sandwich of geotextile with a concrete cement mortar uncured in it. Virginia DOT has been using this, and you dewater the pipe, you roll it out. Depending on the width of the invert that you're doing, you can either longitudinally roll it out or do it in a shingle pattern as shown in the photo. Hydrate it, basically spray water on it, allow it to cure, and then restore your stream flow. And then you've got this, concrete and geotextile sandwich that's protecting your invert. If you have joints that are separating and going bad, there are methods to repair those. You can use internal bands, internal joint seals. You can do flexible grout injection or concrete collars. So these are internal bands, and this was on a reline project, but internal bands can be used in some applications for existing pipes if the joints are separating or leaking, but not misaligned too badly. These internal bands are soil tight, not necessarily watertight, and the bands are placed over the joint and they are tightened into place with threaded rods. And you can see the threaded rods at about 4 o'clock and 8 o'clock positions. Now, the challenge with these is if you have a culvert or a waterway that carries a fair amount of debris, these can be a snagging potential and can catch debris under higher flow situations. So just be aware of that if you're using this method. Flexible chemical grout injection. It may be the foam, it may be cementitious grout, and that can get injected into the joints. I had mentioned the project where the joints opened up because of settlement, and on that project we used a grout foam injection into the openings, and that seemed to have sealed everything up and prevented the joints from leaking and losing soil into that culvert. This, and if all else fails, and if you have to go get out the more intense, destructive, big gun kind of things, you can do a concrete collar. This isn't done from the inside, and you have to excavate out around it and basically pour a concrete collar beneath and around, and it encases the whole joint that will seal it up. This is a Florida DOT detail. But the challenge with this is you have to excavate. Okay. Now we get to the relining part. And yes, you can reline your culverts if they're not too badly shot or too badly misshapen. So the options for relining are slip lining, where you basically slide a new slightly smaller diameter or slightly smaller pipe or culvert arch through. You can shotcrete or spin cast, which is concrete, or you can do cured in place pipe. So for slip lining, you can slip line with corrugated metal, round corrugated metal pipe, corrugated metal plate pipe or plate arch, smooth interior metal pipe, which is what you see in the photo, or you can use high density polyethylene plastic pipe. Both the smooth interior corrugated and smooth interior solid poly. So this is a series of photos from when I was working with Washington County, and we had a corrugated arch that had failed or was failing at the water line, and we did a reline with this. The footings were fine, and we didn't really want to have to close the road for an extended period of time. So we rebuilt this arch and slid it into place to reline it. And the photo C shows it in place, and then the area between the liner and the old pipe was filled with concrete. The photo you see in D is deforming it up, which was a little bit challenging because it was on askew. And this shows the interior of the formwork, and there was a fair amount of carpentry involved to make sure we weren't leaking grout all over the place when we filled that annular space. And the top two photos show how that was done. Basically, we cut into the top of the old pipe at the crown and filled it with self-consolidating concrete. The photo below shows a spiral rib liner, and that was slid into place, slip lined into place. And then the interior shows the photos which point to grout ports, and that was grouted internally to fill that space with grout. This is a solid HDPE pipe, and it's much smaller, and to grout these grout tubes of various lengths and positions were inserted into that annular space, and grout was pumped in using those. So if your culvert has some distortions which make slip lining infeasible, shotcrete or spin casting may be an option. And basically what these are is projecting concrete onto the interior surface, and you get a uniform thickness and create a new concrete culvert inside it. As with anything else, you need to clean it out first, grout in any voids, fill them. But spin casting and shotcrete are a lot more forgiving of distortions and irregularities in shape. And here's a relatively tight space being shotcreted. And as you can see from the photo, the shape is irregular. So getting something to slip line that is going to be very challenging. Another possibility is cured in place pipe. And this is a resin impregnated felt liner. Basically, it's a polymeric felt that's impregnated with a like epoxy type of resin, and it is slid. It's inserted into place and inflated either with water or hot air to push the liner against the existing hose pipe, and then it's either steam or hot water cured. Some of the manufacturers deliver it inside out, kind of like if you're folding a sock. And in the series of photos, you can see they have the inversion or inflation tube, and then they fill that with water and just gradually feed it in, and it gets pushed against the existing pipe. And then once it's fully inserted, the water is heated or steam is pumped in to cure that pipe.
Another question.
Sure.
What criteria is used to determine whether to reline versus replace?
Cost or feasibility. If you're under a 60-foot fill and you're going to have to close the road for weeks to excavate that all out and put a new pipe in, it's probably going to be more economical to do a reline if you can feasibly maintain the hydraulic capacity you need with the lined condition. Sometimes you just can't close the road, and sometimes it's cheaper just to dig it up and replace it. You have to look at the particular case.
And then we have off of that one, would reline hinders hydraulic capacity of the pipes?
Yes, it does, depending on how much of a penalty you are taking with the cross-sectional area. It can. However, some of the reline options have better hydraulic characteristics. For example, if you're going from a corrugated metal pipe to a smooth interior polyethylene reline or a smooth steel reline, and you don't have inlet or outlet control, you'll have better, even with the smaller cross-sectional area, you may have as good or better capacity. But it depends on your specific situation.
And then one more, is it still going to be as strong as the original pipe?
In some cases, stronger, depending on what you choose.
Perfect. That is it for now.
Okay. Okay, so and back on the cured in place, this is the end once it's been inserted. And after it's been cured, that gets cut apart, that gets cut off, and you have a pipe relined. So, footing repair of bottomless culverts. We got a lot of bottomless culverts. This is basic concrete repair 101. But the challenge is stream diversions, you're working in tight spaces, and trying to get to the extent of where your deteriorated concrete is and getting all the unsound concrete out. And sometimes you need to extend those repairs well below scour or potential scour depth. So here's one where the corrugated metal arch is just fine. There's nothing really wrong with it. A little bit of corrosion on the channel that's supporting it, but the concrete is not good. So you have to do a bypass. And this was as the bypass was being set up, everything was going to be diverted through these polyethylene pipes. Then removing all the unsound concrete, repairing or replacing reinforcing steel, cleaning and pouring. And then if you're dealing with concrete repairs, you may or may not use a bonding agent, depending on what your practice is. Place and cure concrete, and then get the forms out of there and restore your flow. So we have discussed common deficiencies. We have described PM, and we have reviewed repair methods. So we got a few questions. Corrosion in metal pipes can lead to which of the following deficiencies? Invert damage, deformation, undermining, or all of the above?
Willie, we have people answering, and everyone, there's a couple people saying invert damage, but mostly everyone is saying all of the above.
Okay, so let's see. So the answer we're looking for is actually all of the above. Corrosion can lead to everything. I don't know why that check mark came up. So, question 2. What would be a PM method for prevention of scour? Riprap or concrete apron, toe or cutoff wall, slip lining or cured in place, installation of geosynthetic composite mat or armor plate, A and B only, or all of the above?
All right, answers are coming in. We have about 70% of the people saying A and B only, about 30% saying all of the above.
Okay, so we are looking for A and B only because the riprap and concrete apron, toe or cutoff wall will prevent that. Slip lining or armor plate could potentially increase velocities through the culvert in and out, which could possibly exacerbate any scour. So increasing velocities could increase scour potential. So A and B only is what we were looking for. Okay. Now, which is not a viable method of lining a culvert with significant deformations? Cat cured in place, shotcrete, slip lining, or none of the above.
All right,
Yep.
it looks like, let me just end the poll. Would share the results with you.
Okay, so what we're looking for is slip lining, and this question I probably should reword it to with to rather than significant, more than minimal deformations. Because if it has truly significant deformations, you may want to give a hard look at replacing. But if you have deformations that are big enough that make slip lining infeasible, shotcrete or cured in place would be the way to go. Okay, so any questions? And that concludes my discussion of keeping culverts well. I want to thank everyone for joining and participating.
Willie, we have two questions.
Okay.
Well, actually, one looks like a comment that says
Okay.
that the cured in place can be UV cured rather than heat cured, which is true.
That is true.
Yep. There are brands that do that.
Yeah.
You have a picture that he wanted to know why the last structure was a culvert rather than a bridge. This is, I guess, the picture just before you got to the questions.
Because it was less than 20 feet.
Right, which is a culvert by federal definition,
Right.
but not necessarily state case law definition.
And also by the behavioral definition, it's not a bridge strictly speaking with abutments, and
Right.
it could be submerged.
Yep. And that's to me is the more important thing is the engineering characteristics. Yep. Okay. That's all we've got.
Okay. Thank you,
Thanks, Willie.
everyone. Thanks.